Okay, let's review for our Module 1 Topic 2 test. If we are looking at our similar figures, let's first highlight so we can know what matches what. We have KL. KL would match RS. We see LM would match ST. Then we see MN would match TU. And then we're going to look at the first and last. If I look at first, it's K and N. The last is N. My first is R and my last is U. So now I know what matches. So what I'm going to do is I'm actually going to do it as figure 1, figure 2. They might have written it different, but I'm going to show you an easy way to test it. So if I'm looking at this, I see they picked 7 and X. They might have put it up and down, but that's totally fine. So I'm going to say on my figure 1, I'm choosing 7 and X. I then look to see what matches on figure 2. 7 matches 14 and X matches 16. So now if they have set theirs up correctly, I would be able to pretend I'm starting to solve this and see if I'm multiplying these same things together. So I should be multiplying 7 times 16, my diagonals. That's correct. Then I should divide by 14. That one's also correct. So I know that is the correct answer. So I'm good to go there. I then look at my next one. I see 7 and 20, or I see 7 and 24, whichever way they've written it. I automatically know right then my 7 has to be with a 14. So I automatically know that cannot be the right answer. So let's look at C. They are using Y and 24 from this figure. So we can say that's figure 1 and figure 2. So you're more than welcome to move around your figures, switch them, whichever. And they are using Y and 24. Even though it's not set up like that one right there, we're totally fine. I'm going to show you the trick. So Y matches 20 on my other one, and 24 matches 12. That one actually matches exactly. You could test your multiplication. 20 times 24. Yes, that's what I should multiplying. And dividing by a 12. So there's my other answer. I can then check D, and I see they put X with either 12 or 24. I automatically know my X has to match with 16. So I know that's not correct. Okay, so let's look at this one to make sure we didn't mess up on E. They used from the, we're going to change this, figure 1, figure 2, they used X and 20. So figure 1, figure 2 equals blank, you have X and 20. It's okay if I put my X first, no big deal. So if I have X, I know it has to match 16. If I have 20, I know it has to match Y. Oh, that 20 is not matching Y because there's not a Y in that problem. So as you see, A and C were your correct answers. Now we're going to dilation the rest of the problems. Okay, this might totally be different than your teacher teaches you, but it works just the same as they do. First thing I do is I highlight my original. I then gonna put a little highlight over here because I know I'm gonna set my problem up as new over original equals blank. And I know my original is my highlight. Okay, now you're used to writing an order pair. That's totally fine. You can do that, or you can say, okay, I'm just gonna take the X of that problem or the Y. I'm actually going to choose P. So that means I'm gonna have to look at P prime first. I want to use the Y of that order pair. I see my order pairs at -2, 6. I'm going to go across and I see my Y is at 6. So I'm going to write that 6. I used my Y-axis, so I also have to use my Y-axis on my original, which is 12. Then you're going to reduce 6 over 12. 6 goes into 6 once, and 6 goes into 12 two. So your rule should be 1/2 x, 1/2 y. Number 3. Which does not preserve congruency? Well, let's talk about translations, reflections, rotations, and dilation. Which one does not preserve congruency? Means same shape, same size. That would be dilation. Does not preserve congruency. Okay, so which one of these means dilation? Multiply. When we dilation, scale factor means to multiply. So I know I have to use the one that's multiplying, and automatically A is my answer. So let's look at 4. You had one like this on a bell ringer. You were just writing this as the rule. Well, if you have a scale factor of 4, that would be xy, 4x, 4y. If you have a scale factor of 1/4, you would have 1/4 x, 1/4 y. Number 5. As we see right here, we have dx, dy. So I know d is my scale factor. So let's figure out what d stands for. I see my new n is at 7, 7. I see my original n is at 2, oh sorry, that's a 7, 7. I said 7, 7. 2, 2. It doesn't matter which one you use, x, y, they're both going to be the same. I only need 1 to find my scale factor of d, so my scale factor is 7 over 2. Could you make that into a decimal? You sure can, which would be 3.5, but you do not have to. You can leave it as 7 over 2x, 7 over 2y. Number 6. A triangle is graphed on the coordinate plane with its vertices A23, B43, and C36. The triangle is dilated with center of dilation at the origin. It's always going to say that because you always dilate over 0, 0. To make a scale factor of k resulting in A prime, B prime, C prime. Which statement does not always true about the image of A prime, B prime, C prime? Okay, k is your scale factor. So remember, k is my scale factor. So if the scale factor is greater than 1, the triangle is larger than the original image. Yes, when it's greater than 1, it is larger. If k, or the scale factor, is between 0 and 1, doesn't that mean less than 1? The figure is smaller. If k is negative, the image triangle is reflected over the origin. So if you're changing the sign, you are just reflecting it, so yes, it is negative. If k is equal to 1, the image of the triangle is smaller than the original. We just said if it's equal to 1, it's going to be the same figure, same size, same shape, so it is not going to be smaller, it would be congruent. So your answer is D. Number 7. Circle 1 was dilated with the origin as the center of dilation to create 2. So my original is 1. And look at our answer choices. Which one of those do not mean dilation? C and D, those are translations, they are sliding. So get rid of those, then you have less to choose from. We are going to do new over original. You can find ordered pairs, or you could just make this easy. Where is it on my y-axis? Or you could look over here on your x, doesn't matter. Whichever one you choose, you have to stick with it with both circles. So my new is sitting at 8. My original is at 3. So my rule would be 8 over 3x, 8 over 3y. Number 8. Triangle ABC is transformed, recording the rule 2x, 2y to create the triangle A prime, B prime, C prime. Which statement is true? The side lengths of the triangle are half the corresponding side lengths of the triangle ABC. Well, they're 2 times 2. Your scale factor is 2, not a half. The angle measures of A prime, B prime are larger than the corresponding angle measures of triangle ABC. Your prime isn't going to be larger. Nope. The angle measures of triangle A prime, B prime, C prime are different than those of ABC? No, angle measures will always be congruent, so those are not correct. D, the side lengths of the triangles A prime, B prime, C prime are double. Doesn't 2 mean double? It sure does, so your answer is D. Your angle measures are always congruent because they are similar figures. Your side lengths are going to be double since it was 2. If your scale factor was a half, then that would have been a half. Number 9, we have polygon LMNPQR is shown in the coordinate grid in the model shape in the garden in the park. It will be dilated with the origin of the center dilation to give our prime figure. We know Q prime is at 21.7. That is my new because it's my prime one. Then Q original is at 6.2. Remember, you only need one of those sets, so we could use the X or the Y. I would use the Y because it's already reduced. I automatically know it can't be B or C because those are translating. They're sliding. So my answer is D. Number 10. Okay, on number 10, if you're 7th honors, you can mark this out. You are just looking at these 2 columns. Okay? We're preserving congruent means same size, same shape. So a reflection across the x-axis. If you are flipping it across the axis, it is staying the same size, same shape, so it is preserving congruency. If you are rotating it, it is preserving congruence. If you are sliding it 6 to the right and 3 units down, you're preserving congruency. You are not changing its shape or size. But if you're dilating by a scale factor of 3, aren't you making it bigger? So it will not preserve congruency. And number 11, if you're in 8th grade, the triangle RST is graphed on the coordinate plane. The triangle is dilated with the origin at the center of dilation to create triangle R prime, S prime, T prime. The table shows the coordinates of the original vertices and corresponding coordinates of the new vertices after dilation applied. So it does not matter which one you choose. Just don't choose 0 because we can't see what happened. So I'm going to choose, this is my new, this is my original. I see 14 and 4. That's what I'm going to use. I'm going to put 14 over 4. I then know 2 goes into both of those. 2 goes into 14 7 times. 2 goes into 4 2 times. So my rule would be xy, 7 over 2x, 7 over 2y. Could I have chosen this one? I sure could have. I could have done new over original, and it would have been -7 over -2. And a negative and a negative make a positive. So there is your review. Do amazing on your test. Should be a very, very easy test.